the same context like text processing. Last time we have done till this point, if you remember, those who were in the class, we have seen how to lowercase the things, applying the lower str dot lower and the text. Then we have passed the text as this is the text. I have also pasted it to your platform such that you can do it. And I believe all of you would have repeated and did the wonderful homework for you such that you understand that what is the cleaning of text is meant actually. So this is the data frame. Those who are new, I must tell you that data frame is a kind of tabular thing where whatever is entered, whether it's a number, text, video, image, website, link, URLs, whatsoever, it must look like a table. Hence, in Python, we call it data frame. Okay, Thomas, Shravan. So this is what we have. Yeah, this is what we have covered last time, converting everything in a data set into a lower one. So str.lower serves the purpose well. Then removing the HTML tags. Let me make it this. This was the HTML tag we were having. Like these are the HTML tags. So I have given the re.compile, regular expression dot compile, and this thing. This is the key concept that whatever you pass inside the bracket in re.compile, similar things shall be compiled for you. So I'm just doing the revision right now. So this, after compiling this, we have seen that all the tab, must I say, all the HTML kind of thing, which you see in a website page, where you find the information of a website page or an HTML page. So all the HTML tag like small bracket, large right angle bracket, star, question mark, comma, backslash, forward slash, such things are actually clean, except the backslash n. That because that is a literal considered in Python. So removing URLs, to remove the URL, I have let you understand that this is the damn embedded thing which you have to write, else the problem might occur. So just save this line somewhere as a URL compile and paste it every time, or simply call the function like we have called remove URL. What text you want to remove the URL from, and see the URL is removed here. Visit my website and it has shown the output after removing the URL. Then we have seen, okay, had we seen removing the punctuation? Yes or no? Guys, those who are present, please answer me. Had we seen removing punctuation?
We are unable to see, sir. Actually, this looking like it's very small. I'm watching on the mobile now.
Thomas, mobile won't serve the purpose. I'm sorry. In the mobile, you have to enlarge your screen like this.
Okay, sir. Okay.
Okay. So, Jen, Mirajuddin, Jen, Mithai, Srinivas, Shanesh, had we covered this removing punctuation last time or no? Nobody is answering me where the dash there.
Yes, sir. Yes, sir. Last time we did.
Okay, thank you, Sanish. So these are the punctuations in English language which occurs, and here is the one line of code which we need to write to remove them. That is the one thing. Okay. Therefrom, I'll now continue as a form of a video that you understand after removing the punctuation. Okay, this is the faster way of removing the punctuation. Let me copy this to you such that when you find something that it is not getting removed, can you see here? This question mark is not getting removed here. Question mark hasn't been removed when you applied this as a remove punctuation. But here, when you used a faster function to remove the punctuation, even the question mark has been removed. So this is a newer thing. Let me copy it for you. I think where should I paste it? 1 second. Am I already here? Yes, I'm already here in a chat. Okay, so this is the function. So do try it. I have given you in the text as a chat text. Now, here from I'll share the video and do let me know whether are you able to hear the sound or no. You share.
Yes.
Yes, please. 1 second. Are you able to listen to me? Yes or no? In the video.
Yeah,
No.
Okay. No.
your voice is only coming, but video is not showing.
Is is my screen showing the video?
Your picture is showing, but just the picture is showing.
I have stopped it. I have stopped it. I have just ran it for a few seconds. Were you been able to listen to it? Yes or no?
We are listening you, but your video is not seeing.
Could you
Now
play it again? Now the video is playing, but the voice is can't hear.
voice can't be heard.
Yes, sir. Voice not coming.
Okay, 1 second. Let me check. Last time share sound, I think, right? 1 second. Now do tell.
All the spellings are incorrectly kept, such that to check whether the spelling correction is able to do its job.
Yes, now audible.
Yeah, now clear.
Audible? No? Okay.
Yes.
1 second. Let me put myself to mute at least. This is, I have started from spelling checker. Sorry, this is one chat word treatment. This chat word treatment I'll be taking separately because it's a separate kind of thing. So spelling checker, spelling correction. From this point of view, I'll be explaining there. Thank you. Okay, where should I?
Sooner we have applied this text block. This is a class here. So, and we have created the object for it. Whenever we write something is equals to, it creates an object to it. So we have passed an incorrect text as an argument. So this argument, soon it is being passed. Then we need to check what this text BLB contains. So see here, it has actually done all the corrections here. Sorry, it has done all the correction. It says text BLB contains text blob to be operated over this text. And the operation, after doing the operation, how the operation should be done? Operation should be done using dot correct dot string. So we have to take the what's called text, apply the correct functions to it, and specifying that yes, it is a string. So sooner it is done, see all your misspelled sentences are corrected, and now you are done with all the spelling errors at least. So we have that choice, and for that we use text blob. So it's a new thing to you. First thing was NLTK, then NLP, then we have seen text block. We would also be speculating Spacey, which is a damn used for the production environment where the server end works are supposed to be done. Remove the stop words. If you would have seen this code at your own premises and home comfort. So we need to import the NLTK. This is natural language toolkit. It is associated with natural language. That's the reason it is being given a name of TK, toolkit. It's a kit which contains multiple tools to handle for natural language processing. This is the meaning, how to read it. Then NLTK download dot stop words. So sooner you write this comment, NLTK dot download. So it will be downloading. Right now it has not downloaded anything, mind it. NLTK.download. What to download? Stop words to download. So it has downloaded all the stop words, and here it will show that whatever download you were attempting by the Python notebook is found, and it is true, and it is done. True means it is done. Then by you would check that, yeah, because still mind it, here this stop words is actually given in a single quote. It means it is again given as a character kind of thing, character and string kind of thing, but it is not a keyword right now. So again you have to import the stop words while specifying that in the NLTK corpus you have already the stop words, the list of stop words imported by its name, and then join these stop words in English using this syntax, and see we are separating all the stop words by this particular comma. Say suppose if I rerun this in front of you, I think it must rerun without running the whole file, because now it's getting connected. Sometimes it takes time, sometimes the things are run instantly. See here it is mounting the Google Drive, because the initial it's called the syntax was mount the Google Drive. That's the reason it's mounting the Google Drive. This may take a longer time because minded this is not what's called, it's an interpreting language. It's not a compilation language. And see, it has downloaded the package, and it is true. How to confirm whether it is being done? A single tick has shown it. Sooner you press it, you can see all the words would come, and it is get joined by comma. If you remove this comma and place say backslash and rerun it, see they all will be separated by backslash. Does it make sense, Ella, Eunice, that what is happening here? We are joining all the stop words by a given syntax. It could be space, it could be comma, it could be semicolon, it could be backslash, it could be any syntax of your choice. Yes or no?
Yes, yes.
Thank you. You don't need to memorize it, mind it, because they do not give any meaning directly when written. But whenever they are used inside the sentence, along with the sentence, they add meaning, they add reference, or must I say, they add the part of speech to whom the thing is referring to. Like if I say you, it means I am talking in, say, for second person. If I go for, say, I want to do this, so I'm going for the first person. Like if I go in the tense, in what tense I'm talking in. So such things are being given by these stop words. So always, whenever you are not doing the POS, means the parts of speech kind of thing, please do not remove the stop words before. When a part of speech is required, do not remove the stop words. When there is no part of a speech requirement, special requirement is there, go for it. This is the only precaution to be kept. This is a very damn simple code. We have already seen these stop words is equal to set stop words dot words dot English. Okay, can anybody tell me what's the property of set here? Property of set, I have already discussed in a data structure.
Is it creating a set of these words, or I don't know? Yes?
Try to think, Ella, in terms of what should I say? Okay, say suppose if I give something inside set what would be the output if I do if I add a repetition? Shall the repetition be followed by the output or no?
No.
It means whatever stop words in English language is given inside the set. If they are getting repeated, the output won't be the repetition. It would be a unique set. Make sense? I think someone is messaging. Let me check. All are good. Only 3 of you have joined. I ask what's in for loop. This for word in str text. Str text means the word which is space and join all other words which do not lie in stop word. See, if word not in stop word, and which word? The word which is actually getting iterated in for loop. This for word in str text. Str text means the text which is passed by you and me, the text which is passed by the user. The word, those words, it will check word by word. Sooner, if it finds not in stop words, means them. Not in stop words means them. If it doesn't find inside these stop words, it means it will keep on joining the things. But sooner if it finds, it will return and this empty space. So say if I run it, done, and second, where is that? Yeah. So check. This is one more method. Have you ever been given a context of lambda method? Any one of you? Guys, have you ever been given an introduction to lambda method?
Yes, yes. But I mean, we had it before, but it was a while away.
But
Ago. I mean, yeah,
what does
it's
this?
anonymous variable,
Mhm.
but sometimes it's confusing for us.
So fine, good. Actually, the only thing lambda does when you go for lambda text, mind it, when you go for lambda variable, sorry, lambda function is only applicable to an anonymous. It is also called an anonymous function. Means when you don't know that specific use of a function, you go for lambda and you write what is to be done. So see, here we have written lambda and written something to be done over the text means the input passed by the user. And what is to be done? We have to call the function remove stop words and giving the text or a data frame, anything inside. So then we apply the lambda function and it is being used along with dot apply dot apply method. Dot apply is called method, and inside the dot apply, whatever we use, we call them functions. So this is a data frame of a review which I have used. Now again, I would means I have to upload everything again. So I think you have got the gist. Yes or no? Should I move ahead or should I upload again all the data set and run it? What do you say?
Yeah, it's okay. You can.
Yeah, thank you. So actually, this is the thing it's being done. Sooner after this is being applied, we have seen the how now after the stop word removal, how does our data set look like? So our data set look like this. See, previously it was this review, and after becoming a new, means after it is being applicable over it, after the stop words are being removed, it looks like this. So can you see any difference here? Can you see the difference? Yes or no?
Yes, yes.
All the stop words of these where they are removed. And mind it, it takes capital A and small a differently because it is a what we call a case sensitive language. See here, basically there is a family. Here it is written, there is a family, and this A is not left anymore, but this A is well maintained. Okay, because it considers small letter and capital letter differently. So this was the thing. And as correctly said by Ella, tokenization means you have to convert a set of means a set of sentences into a few means different sentences or one sentence into a different words. So for that, the Python actually introduces the library word tokenize. Sorry, the tokenize is the module, and word tokenize is the class for that. Means it will tokenize the given input, given corpus in terms of words rather than sentences. Say if you have 7 to 8 sentences and you want to tokenize, apply the tokenization to it, means you want to convert it into a small pieces, meaningful pieces, then you would apply sentence tokenization, mind it, because there are so many sentences. So first convert it into a smaller sentence, multiple small sentence. If there's only one or two sentence, just convert every sentence into a word such that it becomes meaningful. And for the while we apply the machine learning, the conversion process becomes easier. Conversion means from text to number, because mind it, get remembered throughout your learning. The whenever we want to let the machine learn, they have to be learned in terms of numbers, and numbers should be created for machines unless until it's a image or a number itself. Because see, why are we working so hard towards NLP? Because if it would have been CV, computer vision, in that situation, image itself is forms of pixels. Yes or no? Can you see any image without a pixel? Either it's be a HD image, or either it be a low definition image, either it be a blurred image. So there are numbers which are playing over your screen, and the input is being understood by the machine in the form of number. That say suppose highest pixel size is 255, whereby the lowest pixel size is 0. I think you can correlate such things. So it's all numbers. So but here you have to think logically that how to convert a text into a number. Then the feature extraction, or what my mail correctly said, that is called the text representation starts. So before text representation, we must be well aware with all the text pre-processing or the text cleaning techniques. So text representation is also known as feature extraction, and it is also known as text vectorization. So mind my words, make an analogy between the things. They are same thing, text vectorization, either a text representation or feature extraction. Do you remember the cycle, the framework, what we discussed on the very first, starting from the data acquisition to the deployment? All these steps comes, and we are going in the same fashion. First, we have watched the text cleaning or pre-processing, the basic cleaning and the advanced cleaning. Then after we would go towards the feature extraction, then the modeling, and then the deployment. Am I understood, guys? Not previously present in the memory, but you have asked to be available in my cache memory, such that whenever I need you be available to support me. That's the meaning of downloading. You are not downloading over your hard disk. Means you are not storing it. You are just keeping it to the Google Collab cache memory. I think the process is getting clear from the cloud to your Windows screen. It is done. See, it will show you the true that we have used the correct syntax to download, and I have used the 3 sentences here. 3 sentences, sentence 1, 2, and 3. I have taken a very typical sentence where I have applied multiples dot, such that let's check whether the tokenization is able to tokenize them or no. So say Sentence 1, sentence 2, sentence 3. Let me start from sentence 1. So see, when I apply word tokenizer, so see, it is able to tokenize every word as a whole. See here, it has not separated D from PhD. It has not separated dot from AI. Isn't it a good thing to understand that it is considering AI as a one word, and it is a one word. It is considering PhD as a one word because it is a one word. Else, what's the basic rule? It must have separated a PhD from dot, PH1 and dot 1 and D1.
Yes.
PH a character, dot a character, and D a character. But it has not done so. Isn't it a good thing about a tokenization? Can
Yeah,
you
yes, it's good.
see what I'm saying?
Yes, yes.
Yeah, thank you. Sooner, when we go for sentence 2, let's have a look. It has literally taken V, R, and see, I have used apostrophes to R. Still, it is able to take V, R as a different sentence. Here again to help different, apostrophe is different. Mind it, help apostrophes is different from help and exclamation. Sorry, it was exclamation, not apostrophes. Help exclamation is one word. Help, comma, explanation are two different words. So here it is able to separate all of them. And to the surprise, hellog@gmail.com. Hello G is one, @ is one, and gmail.com is again a one word. So it is working well. Yes or no?
Yes, it's working.
Sorry,
And
I have a question.
yes, yes.
Okay, so
Yes, Miss.
okay, I have somehow not understood as in why it has not separated the PhD, but it separated the hello at gmail.com.
Okay. Actually, see here. Uh, actually, what do you want it? Do you want PH different and D different? Answer me, Eunice.
Okay, so I thought it's removing, it's separating if there's a stop. I don't know if there's a comma or a dot. So I don't know what's different from the dot that is in ph.d, which is PhD, of course, from a dot as a dot that is in at gmail.com. How does
Yes.
it know if this is different? Yes.
This is the backend learning, the learning given to the word tokenized machine learning algorithm. It's also a learning algorithm, Eunice. So it is being trained in such a way that now it is able to segregate the thing based upon their literal usage, semantic meaning, and frequent usage. Like we already know that being a human, you would consider gmail.com as one thing because .com could also come after the website name. It is not necessarily that it must come after the email ID. Yes or no? Similarly, it is able to learn well. Mind it, whenever the machine is performing good, what do we say? The training efficiency and the testing efficiency, they both are good. The training and the testing accuracy, they both are good. And the training and accuracy loss are very less. It means these word tokenizer and the sentence tokenizer, if it is used, they are performing, they are doing the state of art work. Are you getting? Say, suppose if I would have written here rather than this, if I would have written R rerun, again it has done this. And say if I would have done PhD, one more dot here, suppose, and I'm using the sentence one. Let's check. Always have a try. Give so many permutations and combinations such that you learn that is it being able to do it or no. And see there in front of you, it is able to take PhD altogether because it has learned, it has come to know, it has come to learn from its learning that PhD is used most of the time altogether. Eunice, have you understood
Yes.
it?
Yes, I've
Suppose,
understood. Thank you.
suppose you are trying to, okay, are you married? Personal question. Married or do you have children?
I still have children and I'm married. Yes.
Okay. Suppose you are treating and you are educating your child that, hey, say your the child name is Yunus. Hey Yunus, read it as altogether. Read it as PhD. It is not PH and taking a space and D. One day, don't you believe that your child would be speaking it as a PhD altogether?
Yes.
So this is how the machine is also learning. Whenever you are training your machine, always consider it as a child who know nothing. So that is the reason iterations are to be done to the machine. If you go for multiple iterations, the machine sometimes they cram, they remember everything, and it enters into the zone of overfitting. But many a times, if it is including, must I say, the deep learning concepts, they usually do not overfit. If the data is less, if the data is not less, they usually learn the correct pattern. Like suppose see here, a 5 kilometer ride, if I go for sentence 3, it is able to separate number by a kilometer. Although we have added space also, that this is one of the reason. But see, to the surprise, the dollar and 10.34 are separated. And it has not separated on the basis of dot here. 10.34, $10.34 are taken all together, and dollar is taken as a different entity. So this is the state of art learning happened to this word tokenizer. Okay. Suppose if I made the sense here, I would like to ask you about what do you understand about the stemming and lemmatization, if you have read through. Yes or no?
Yes.
Would be given a different word which is called accept, and it is the root word. Am I correct?
Yes.
Fine. Eunice, any idea about it? Stephen, you too? Okay, no worries if there is no idea. Very correctly said, Ella. See the word. Whenever you are stuck in the very first class, I have given you a hint. Whenever you are stuck in natural language processing, always go to its literal meaning. Literal, what does it mean? Stem. The stem starts from the stem of a plant. Have you seen the stem of a plant? The root of the around near the root, not the root, near the root. Stem. Separate it.
Yeah.
Now do the tokenization. Stemming. So it is seeking the root, not actually able to find the root. Whereby actually the stemming, if I write it, give me just liberty to write that very good definition I found for stemming. It is, I don't worry, I'll share this whole notebook with you. It is the process of reducing inflection in words their root forms. And can anybody know the meaning of inflection? Have you ever seen that in a grammar, that inflection is actually there's a modification in a word to express different grammatical categories, such as in what mood the one is, what is the case, in what tense the grammar is being spoken, is in present, past participle, present participle, or what's the gender talking to, what's the mood of the sentence, what's the mood of the character. So such things are called inflections. So Stemming is actually the process of reducing, not means not making it zero, reducing the inflection, such moods, tenses, variability in the aspects and the context in words to their root forms. Like, as you said, acceptance. Acceptance means something is accepted by willingly or unwillingly. So this acceptance could be willing or unwillingly. But without seeking, means without maintaining the morphological meaning, it has straight away reduced the acceptance to accept, whereby lemmatization do not do such things. It maintains the morphological meaning. It also converts the main thing to its root. Say we have walking, ox, say walker, है ना? So what stemming would do? Stemming would convert all the things to walk. Do you agree, Ella? Stemming would convert all these to walk. Whereby, say suppose here we have one more example. You must have seen the presentation. It is being shown to you. Say if I use a different color, do I have the ability? Yeah, I can choose that. Here, if here I do use, if I word caring, if I use stemming, caring is converted to car, but lemmatization at the same meaning, it will convert it to care. Now, do you get what do I mean to say?
Yes.
Yeah.
So it is able to maintain the morphology in what context it is being used. And one thing to remember, that stemming, okay, mind it, suppose you want to show the project to your reporting manager, and this caring is converted to car, would you be able to show your face to him or her, that what your model is doing, it's converting the care kind of thing to a locomotive? Okay, so when you don't want to show your output to the stakeholders or the sponsors, we use stemming. Okay, are you getting what did I say?
No, could you
While
please repeat again?
use stemming when you don't want to show the output to the stakeholders. And definitely it is a fast process. Use when speed matters. When you don't want to show your output to anyone and speed matters, use stemming. But when you have the accountability, when you are accountable for your output, use lemmatization, but that would be slow. Is this input well taken?
Yes, sir. So, at what point it is the best to like use stemming and or to use lemmatization?
Lemmatization.
If one is
I
fast.
said no. I said no. There are two parameters to decide unison. First is when you don't want your stakeholder to see your output. Means when you don't have, means your stakeholder only want the speed. It must happen fast. Like when okay, have you seen the chatbots working in what's called live sale or big billion sale? Here in India, we have Amazon, Flipkart. There a big billion sale runs every 3 months or every quarter it runs. So there we don't want our these things to be seen by the stakeholder. We only want the interaction between the user and what is called the chat bot. And we also want speed, because sooner, say suppose the response is slow, the user will switch to a different website or a different application. So the purchase would be hindered. Are you getting what I'm trying to say? So whenever the speed matters and the business problem in the business problem, your stakeholder or the sponsors do not want to see your output, use stemming, because you have seen that stemming do such bullshit answers, caring to it becomes car. So you don't want to reflect your model like this. So if you can afford for uh, few such errors, go for stemming. Else, if you are accountable for every output, it is representing to the screen at the stake of speed, although it would be a bit slow rather than stemming. It won't be like your screen got hanged. It won't happen like that. But it would be slow comparable to stemming. Because see, why it is slow? Because lemmatization is a searching process. And searching is a slow process. Have you seen in a data structure that searching, whether it's a Boolean search, quick search, or a decision search, it's a slow process. And when to use what? First of all, say suppose, where is this? Yes. Say suppose, always use either stemming or lemmatization while information retrieval. Information retrieval. Like Google also do. All the search engines apply these two techniques, whether it be a Google or a Bing or Yahoo, or it could be a what's called Microsoft and Edge. So all the search engines are using information retrieval to retrieve the information that if a user has entered a keyword, it will tokenize it using stemming and lemmatization. Then it will also apply TF, IDF kind of things, which we shall see later. But information retrieval, whenever you require it, go for stemming and lemmatization. Is it understood? Eunice, Ella, Stephen, has anybody else joined? Let me check. Yes, thank you. So what the algorithm used by either stemming or lemmatization is also called the porter one. Porter. The porter is used for English language, whereby you also find one more algorithm called snowball. Have you heard either of them?
No, for me.
Snowball is used for any other language than English. Other languages. For English, only use porter. So these are the things to be taken care of. And one thing to give you one very good example regarding stemming. Say suppose once I give the word probably, okay? Probably. What do you say that to what it must have converted it to? Any idea?
Tropical.
I am
Probably.
asking, according to English language, it must convert it to probable.
Tropical, yes.
Probable, but it has not converted minded to it probable. It has converted to dear. It has converted to probable. That's it. It just removed y. So from this, we can add one information to our definition of stemming. What we have read, it is the process of reducing inflection in words to their root forms. Okay. Even here we need to write, even if the stem itself is not a valid word in the language. Is probable a valid word in the language?
No.
is probable a valid word in the language?
No.
No. So we have learned that stemming can convert to a given word to such a word, considering it to be a stem, and stem need not to be a valid word in the language. So it might create blunders. Okay. So thereby, when it was converting here to car, it was changing the semantic meaning, or it was changing all the meanings. But although the car do exist in the language, the word car exists in the language, whereby this probable do not even exist in the language. Let me show you the code if I have. Let me check.
Yes, guys. What have you learned today?
Stemming and lamentation, totalization.
So
No,
was it?
one thing.
Yes.
Actually, why we were using this tokenization?
Okay. Say, Genji, whenever we are using the tokenization, it is only, say, suppose if you are only written a small word, small sentence, I must say, like say, I am an Indian, I love my country, and I am a quite patriotic person. So it's a simple sentence I have written. So whenever I want to means convert my sentence into the small pieces of words, I'll call it tokenization, first thing. But
Okay.
when I have a very big document, let's suppose 5 to 8 paragraphs in a document, then I have to tokenize the document itself into sentences. First, I have covered, say, when I was having a small sentence, I converted into words because words are the lowest thing which makes sense. I cannot convert into letter, no, because letter has what may I say, no meaning drawn. If I say
Given words, it's a sentence.
yes, whenever sentences are there, convert it into words. Like say, suppose last time, if I share the screen, last time we had sentences like good morning, have you had your breakfast? Do you remember our last?
Yes.
See, I think here, see, we had a sentence.
Stream
Good
law
morning.
that case.
Yeah. Good morning, dear. Hope you had a great day today. Have you had your breakfast today? So this is a sentence which needs to be tokenized such that good is a different word, morning is a different word, dear is a different word, and every word is actually kept into a vocabulary, must I say, because this is also a document to a NLP, natural language processing, or a text processing. This is a document, but a small document. So whenever there's only one sentence or two sentences, we apply word tokenization, means convert the sentence into word. But when we have a very large sentences, 5, 3, 7, 8, 24, 782, this big volume of sentences, big volume of document, first we convert into sentence, and then after applying the sentence tokenization, we again convert them into word. So the smallest tokenizer in this kind of thing would be word. Am I understood?
Yes.
Yeah.
So I think today you have enriched your knowledge with the tokenizer, stemming, lemmatization. And have you seen what the blender